Very good morning, students. Today topic is the chapter 1 protective relays. Okay, so in the topic classification of protective schemes. Okay, so in the previous classes we have discussed about the different protections. Okay, so different methods of protection. Now we'll go for the topic that is classification of protective schemes. So in the classification, so in the protective schemes are classified into the four types. That is first one, we were having the overcurrent protection. So first one is having the overcurrent protection. So here is the overcurrent protection, and second one is the distance protection, carrier current protection, differential protection. Okay, so here the overcurrent protection. So this scheme is mainly used for the production of transmission lines. Okay, so large motors we are using, and distance type. Okay, so this is the overcurrent protection is the meeting. Okay. So overcurrent protection lines, it is used for the protection of lines and large motors. And here coming to the distance protection. So distance protection is used for protection of transmission lines. Okay, and sub-transient lines. Okay, usually 33 kV, 66 kV, and 132 kV lines. Okay, so use it for the is the distance protection. And carrier current protection. So the carrier current protection used scheme for the protection of EHV lines. So this is for used for the EHV and UHV lines. Okay, so this is for the distribution. So overcurrent protection for distribution lines and distance protection for the transmission lines and carrier protection for UHV. Okay, extra high voltage, ultra extra high voltage lines. Okay, so general is a 132 kV above. Okay, so whatever the 132 kV above lines is there, so that will go for the carrier current protection. And next we having the differential protection. So this differential protection is used for the protection of generators, transformers. Okay, so generator, transformers, and motors, and large size motors. So this is for the this. So here this one is each one. Okay, so overcurrent protection, distance protection, carrier current protection, differential so from different the all are includes different types. Okay, so each topic we are going to learn. Okay, next to further chapters, that is chapter 2, chapter 3, chapter 4. So we are going to discuss the each of the topic. Okay, so overcurrent protection, distance protection, carrier current protection, differential protection. So all are the one of the chapters. Okay, so we'll go deeply with the each one. And now we'll go for the overcurrent protection. So overcurrent protection used for the lines of distribution line. And here this will having the use for the protection of large motors and equipment. So here it includes, so it includes one or more overcurrent relays. Okay, one or more overcurrent relays. One or more overcurrent relays. And overcurrent relay operates when current exceeds its pickup value. Okay, so it operates when current exceeds its pickup value. Current exceeds its pickup value. Okay, so use it for the overcurrent protection, used for the distribution line. Okay, so overcurrent protection used for the distribution line and used for the large motors and equipment. So it's more one or more overcurrent relays. Okay, so one or more overcurrent used and overcurrent mainly. So it will, how it will work means it will operate when current exceeds its pickup value. So we are having time setting is there. So pickup value will be different. Okay, so whenever it exceeds its normal rated pick value. Okay, so if it exceeds the overcurrent, okay, so that is a what is the predetermined value of the current is there. Okay, so then after that only it will be starts operating. Okay, this is the overcurrent protection. Next, we'll talk about the distance protection. So distance protection. So in the distance protection, used for the protection of transmission line. Okay, so it is used for protection of transmission lines and sub transmission lines. We can say that below 33 kV. Okay, so sorry, 33 kV, 66 kV sub transmission lines we can say. Okay, so that is a 33 kV, 66 kV and 132 kV lines. Okay, so that will come to the distance protection. Okay, so it includes the number of distance. Okay, so it will be including the number of distance relays. Number of distance relay of the same or different type. Okay, so it may include the same type relay or different relay. Same or different relays. So the distance relay is nothing but a relay measures the distance between the relay location and point of the fault. Okay, so the distance relay what will do, so it will measure the fault where. Okay, so where is the fault is there in terms of impedance. Okay, so it will measures, so the distance relay, okay, so measures the fault location. Okay, so in term location the point of the fault. Okay, so location and point of the fault in terms of, so how it will be clarified, that is by using the impedance value. Okay, so impedance and reactance, so based upon the reactance impedance value, so we will measure the where is the fault is occur. Okay, so where is the fault is occur and how much distance it will occur, that will be. So the relay operates within the, okay, so operates if the point of the fault lies within the protected section, that is the if the protective sections is there. Okay, so within the limit it can measure. Okay, and the important types of the impedance are the reactance and mode type. So impedance relay measure the lines impedance between the fault and the relay. Okay, so here we are having the more relay impedance relays where we can use. So mainly, so it will in this type of protection, so where is the fault is occur, so the fault location we can easily find by using the impedance reactance of them. Okay, so mainly which types of relays we are using, so impedance relay and more relay. Okay, so these are the types we are using in the distance protection. Okay, so distance protection is used for the transmission line and transmission line, that is a 33 kV, 66 kV, 132 kV. So it includes number of distance relays or different types also, so we can do same types of distance relays or different types of relays. Okay, and so here the distance relay is the measured the, okay, so distance relay measured the distance between the relay location and the fault point. Okay, so measure the distance between the relay location and fault point of the terms. Okay, so by using in terms of the impedance and reactance. Okay, so here there are the most types impedance are the impedance types, more relay. Okay, so reactance relay types also there. Okay, so these impedance relay, okay, we can say that in terms, so it will measures that in terms of impedance, the more relay, so measure the component of the admittance. Okay, so that's the tip. So how it will measurement, so the input it will be takes, that is in terms of impedance and admittance and reactance. So based upon inputs, these distance type of protection we can use. Okay, so in detail the which type of the relay we are having, the distance type relay, impedance relay, more relay, so reactance relay, so that will be discussed in the each chapter. Okay, next we will having the carrier current protection. So next we are having the carrier current protection. So in the carrier kite protection is used for the, so here this will be used for the UHV, okay, EHV, sorry, EHV and UHV, okay, extra high voltage and ultra extra high voltage, okay, so which will having the above 132 kV lines, we can use it for this type of protection, okay. So okay, so carrier signal, okay, so here we'll be using the mainly as the one carrier signal. So carrier signal we are using, that is in range of the 50 to 500 case, okay, so generated. So in the transmitter reason, okay, so here we are having the transmitter and receivers are insulate each other and transmission lines are protected, okay. So in the information, so it will be in the form of the signal sign, okay. So this signal, so it will be used for the end of the line, okay. So depend upon informations relay here, so used for the EHV and UHV line, okay, and it will use in the one carrier signal, okay. So here we are having the a transmitter and receiver, okay. So transmitter receiver are installed at each end of the line, okay. So both ends of the line will install the one transmitter and receiver, okay. So transmitter receiver and information regarding the direction of the fault current, okay. The information if the fault current is occurred one direction, okay. So the relay, so fault current is transmitted from the end of the line, so each end of the line, if the fault direction is the, that will be transmitted to both sides, okay. So and relay placed in the each trip, okay, so it will place in the within the their protection. So here also they are in the protected zones also there. So from that one, so it will be where the carrier signal will flow, so where the fault occur, so at what directions the current is flowing, okay. So based upon that, the relay will trip, okay. So relays do not trip in case of external, so if any external faults is there, okay, it will die down. The relay are distance types and their tripping operations controlled by the carrier. So here the relays are the distance type, okay. So here also we are using the distance type relays, so we are using the distance type relay. So the controlling is by using the carrier signal work, that's it. So here is a carrier current protection setting bar, so use it for the EHV and UHV line, so extra high voltage and ultra high voltage line. So and that is for 132 kV line, okay. So a carrier signal of the range, that is a 50 to 500 kc by seconds, okay. Carrier signals range is used for generate the purpose, okay. So here each end in the transmission line in this type of protection, so in the scheme, so both ends will having the transmitter and receiver, okay. So here whenever the fault direction is up, okay, so it will be when the fault is occurred there, so here which direction is flowing, okay. So fault current which direction is flowing, okay, that will be given to the transmission, and that then well, if the predetermined, okay, so based upon direction relay, so distance relay, so in the protected zone where the relay is working there, so then it will be tripped up. So if any external faults is still, okay, that will be not detected in this type, okay. So only so internal, that is the variations in the current directions only, then it will be easy, okay. So here in this type, so we are protection, so mainly we are using the distance type relays are used, and here that will be controlled by the carrier signal, okay. Next we'll talk about the differential type. So this is a main type of the protection, differential protection. So in this type of protection, okay, so here the scheme is used for the protection of a generator. So this is the main important generation protection, differential protection, that will be used for the generators. So it will be used for the generators, transformers and large motors, Okay, so in case of the irrigation system, if you the motors are large size there, okay, and that will become. And here's the bus bar zones also we can use. Okay, large size bus bar zones is there. Okay, so here use for the differential type protection. So here in this type of the protection, so if the bus bar is there, okay, so both place, so each one, okay, so each one we are each one we are placing the relays. Okay, so CTs, PTs were placing. Okay, CTs are placed both sides of the each winding of the machine. Okay, if it in case the one bus bar is there. Okay, so let us suppose we are having the, if the machine, okay, so if the machine put on, so both sides we are placing the CTs for each phases. Okay, the output of the their second is applied to the relay coil. So what the output is there, so here having the relay coil in between there. Okay, and the relay, okay, so what will do, the relay will compare the input and output. So current entering the machine winding and leaving the cell. Okay, so both input and output currents will be measured by the seat. And whenever the, if the variation is there, then only this relay coil, okay, so then it is tripped. So under normal condition during the external fault, okay, the current entering the winding is equal to the current leaving. Okay, but in case of internal fault, okay, so but if in case of internal faults, so what will do, so current leaving winding those are not equal. Okay, so current leaving input, okay, so current entering the current entering the into the input side and current out leaving the output, so that will be, so then the relay will activate. Okay, so here the relay operates for the internal faults and remains inoperative under normal condition. Okay, so during the external faults will work. So in case of the bus zone protection, okay, so in case of bus zone protection, CTs are placed at the both sides. So we can say this diagram. Okay, so both sides, so input side and output side, they will placing the each phase. Okay, that is a differential. So it may be a transformer, it may be a generator, it may be a large side motor. So whatever the protection is for each one, the entering current entering the input side and output side, we are placing the, that is a each phases we are placing the CT. So here mainly the working is done by the only the CTs. Okay, that is the differential protection. So each step, so in the differential type protection we are having the generators, transformer, large size motors, bus bar zones. Okay, so we are having the pilot system also there. Okay, so different types of the protection we have. Okay, so this is about the classifications of protective system. Okay, so what we have discussed, let me recap. So we had talked about the protective schemes. So in the protective scheme, we have in the overcurrent protection, distance protection, carrier current protection, differential protection. So here the protective schemes. Okay, so which type of the protection we are used for at what situation? So for overcurrent, so the overcurrent protection scheme is used for the distribution line, and in next distance protection, so distance type protections used for the transmission line and sub transmission line, so that will having the 33 kV, 66 kV and 132 kV. Okay, and next we are having the, so carrier current protection. So this carrier current, so sorry, okay, in the distance protections we are having the transmission lines, right? So this transmission line, so based on so based on the impedance. Okay, so based upon impedance, admittance, reactance, so this distance protection will. And coming to the carrier current, so here carrier current also we use in the, that is the distance, but so mainly the current control, so it's the internal current control, so current carrying signal. Okay, so carrier signal used for the protection. So here both ends of the line we are placing the transmission and receiver. So based upon the current direction it will be work. Okay, so here in the, that is the, okay, next this differential protection. So in the differential protection, so that is a mainly here it will use it for the generators, transformers, large side motors and bus zones. So here each phase, okay, so for input and output side we are placing the this type of protection, we are placing the, that is a current transformers at the both ends. Okay, so it will measure the input current and leaving current. Okay, so entering current and living current. So based upon the variations it will be felt. Okay, so this is about the classifications of protective schemes. Next we will talk about the automatic reclosing. Okay, so how it will be reclosing if the fault occur. Okay, so let me take the example. So if the system, the bus bar road, and here I'm the circuit breaker, and here we having the CT. Okay, so which are connected, and here we have connected the trip system to the line. So here is a trip coil. Okay, so here is the CT and here is the relay car. So here what we'll do, so when fault is occur, okay, so when the here we're having the bus bar and here having the circuit breaker. So here the circuit breaker. So when the fault is occur, okay, so at the fault condition what will do, the current input, okay, that will be, so at what time, okay, so if the current is varied for the 5 seconds or 2 seconds, okay, then it will be normal. Okay, at the time what you have to do, the circuit breaker should reclose the automatically. Okay, the circuit breaker will have to reclose them. So that is the that fault. Okay, the whatever the fault is there, okay, so is in the transient nature, if the transient nature. Okay, so if the, so about the 90% of the fault, okay, so on the overhead lines are the transient nature. Okay, so transient faults always caused by the lightning and external fault. Okay, so if the lines, so external faults is same. Okay, so based upon the, that is the lightning, due to the lightning or external bodies of the falling on the line. Okay, such faults are always associated with the arc. Okay, and if the line is disconnected from the different system for short line. Okay, if the line, if the, this is the line. Okay, so if the line is the disconnected from the system for a short time, the arc is extended and fault is disappear. Okay, so immediately after the this time the circuit can be reclosed automatically and restore the supply. So at what time, okay, so most of the lines in the EHV lines are caused by the lightning and flash or voltage, and due to the over voltage caused by the line. So whatever the faults is occurred on the transmission line and EHV lines, UHV lines, so that is a mainly occurs of the uh, that is caused by the flash or voltages. Okay, so insulation failure or lightnings, that will then. Okay, so at that time we have to do, so should in a short time. Okay, so it will having the short time faults, that is the, we can say the transient faults, we can say that is the transient fault. Okay, so hence one of the instance recloser used for the EHL. So if there is no need of the more than the one reclose, okay, so at that time, so in the transient, so we have a using the only one recloser should have that. Okay, so for each EHV line, okay, one recloser in 12 cycles is required. Okay, so one recloser in 12 cycles, one recloser for 12 cycles required. At a fast recloser desired from the stability point of view, okay, that is if you want to stability in the transmission stably, okay, so we require the one recloser. Okay, so if the fault is occurred one at a time, okay, so recloser for one, that is after 12 cycles should be in the reclose. Okay, so in the uh, each one, okay, so it should be in the after every transit, so after fault is clear should have the reclose that one. Okay, so and the lines of 33 km. Okay, so in case of 33 km, so most are classified by the external object such as if in case of 33 km lines are there. Okay, so if the, that is a trees, if the fault on the lines, okay, so that will fall. So at the time, so this is a due to the fact of the supporting height of elastic. Okay, so an external object may not be burnt clean. So at the first clip, so in this step, that is the, that is 33 kV line system. Okay, so should the recloser should work, that is the 15 to 30 seconds. Okay, it will wait up to, so additionally, so usually that is the 3 reclosers at 15 to 30 reclose, okay, seconds interval are made to clear the fault. Okay, so according to the reports, okay, so if the first reclose, okay, so all most of the faults are cleared at the, that is a 80% all fall cleared at the first of the first clap, that is a here, that is if the reclose first reclose, second reclose, third reclose means, so here the if the transient is came for the 3 seconds, okay, so if its fault occurred and after the that the arc extension, and then it is, if the fault is clear, then automatically it will be recloses. Okay, there this one plan. So here if this continuously is playing, if the fault is not clear, okay, then it will be again open. Okay, so that is the second side. Okay, so similarly there is a 3, so it is the each way. Okay, so in each reclosing time, that is still having the time. Okay, so based upon the time, that is the in the 33 kV line, so 15 to 30 second, that is the 3 reclosing system. Okay, so 3 reclose at the 15 to 30 seconds the intervals are made. Okay, so that is a, if you want to clear the fault, that is we will take in the 3 recalls at the time of the 15 to 30 seconds. So this is about the automatic reclosing. So most of the time, okay, so in the reclosing part, the first recloser is having the, so 80% recloser, that the first recloser, and 10% is required for the second reclosers, and 2% is for the third recloser. Okay, so while the remaining 8% is in the, this is for the permanent fault. Okay, if the permanent fault, okay, so it will use for the fourth recloser at the time. Okay, then it will continuously open. If the fault, okay, so whatever the fault, if they occurred in the line, so if the, it will not clear the in the 3, okay, so it will not clear the in the 3 reclosers time. Okay, so it indicates that the fault is, that is the fault is in the permanent fault. Okay, so the automatic recloser not used in the queue. Okay, so at the time it's automatically close not used, so it will says that is the permanent fault. And one more thing, so this automatic reclosers, okay, so in the circuit breaker vision, automatic reclosers are not used in the cables. Okay, one down, that is a automatic reclosers are not used in the cables as they break down the insulation cable. Okay, the insulation is failed, that is the if the failure is occurred in the cable, that is the mainly because of the insulation failure. Okay, if the insulation fails until the, that is comes to the permanent fault. Okay, if the, we can say again, so 80% of the fault clear at the one, at the first clue, and 10% the faults is clear at the reclosers at the required 2. Okay, and 2%, only 2% need the third recloser. Okay, so but while the remaining, okay, if the fault is not clear the third reclosers also, that we can say that is a permanent fault. Okay, so and other in the cables, the automatic recalls are not, because if the cable is having the fault means that is mainly because of the insulation failure. So insulation failure comes under the permanent fault, not is in the transient nature. Okay, that is the reclose automatic reclose. Next, we'll talk about the current transformer. So what is the need of the current transformer? Okay, so we'll shortly we write an as a CT. So what is mean by CT? So CT is a transformer. Okay, so it is a current transformer used to reduce the heavy current flowing. So in the current transformers for if the protection system, okay, so current transformers for the protective system is used for the reduce the heavy current flowing element of the power. Okay, so current transformer are used to reduce the heavy current flow. So current transformers used to reducing the heavy current flow in the an element of the power system, low values of the suitable relay operation, because we have to measure the how much current flow in the line. Okay, so if the large current is flow, okay, so it cannot measure by the relay coil. So at that time we have to using the low current value. So for low current values we are using the CT. Okay, the current ratio. Okay, so current transformer rating of the protective relay is usually 5 or 1 ampere. Okay, so current rating of the protective relay usually 5 or 1 ampere. Okay, and the besides the reducing the current level, the seat is also isolate the relay circuit. Okay, the seat is also isolate the relay circuit from the primary circuit and is the high voltage power circuit. Okay, which was the standardized current. Okay, and here the what are the requirement. So if the current transformer we are using, okay, what are the requirements should you have for the current transformer? So what are the requirements for the seating? Okay, so if we are using the current transformer for protective system, what are the requirements should have the seating? Okay, so requirements used for the protection the differential from those instruments, that is the CTs. Okay, so if you want to which are the measurements. Okay, so in the measurement system we are using the CT, right? So for measuring the transmission lines voltage. Okay, so transmission line curve, so that is not same. Okay, so in the protective system which are using for the CTs, so that will not same. Okay, so these are both are the some difference will be there. Okay, and instruments, so a CT used for the instruments are required to be accurate over normal work. Okay, so what the normal working of the current. Okay, so where the CT used for the protective. Okay, so if the protective system we are using the CT at the protective, say if you are using CT, so it have to show the current ratio. Okay, should require the give the current ratio of the several times of the rated one. Okay, whatever the here the 600 amperes of, okay, should he represent the below the 6 amperes or 5 ampere 1 ampere in the form the, okay, should the current ratio, okay, that will be different. So there are several times. Okay, so required to give the correct ratio up to several times of the rated primary current. So is due to the fact of the relay has to perform the reliability at normal current. Okay, so if the fault is occurring, okay, so if the fault condition what have the, so whatever the relay is there, okay, so it will operate have to the CT is measure the whatever the performance value. Okay, so it will what rated value it will be above value. Okay, so at that time should have to measure the above rated current also. Okay, and should will be in the secondary side also, it should be in the uh, normal current. Okay, so at the normal current as well the fault current. Okay, so it will differ with the fault current. So usual the fault currents are the many times of the normal currents. Okay, suppose if the transmission if the distribution line having the 60 amperes of the rating, okay, but if the fault is occur, okay, in the short circuit what will happen, it will goes to the 600 volts. Okay, 600 at that time what have to do, the current transfer they have to withstand. So at the also the current transformer it have to withstand and they give the measurements to the required current rating to the relay. Okay, then only it can be the fault is occurred. Okay, if the 60 amperes only if you placing the CT, so what will happen, so it will damage the equipment and also the signal is not given to the relay coil. Okay, so it should have withstand the more rated voltage of ratings of the system. Okay, that is the current ratio. Okay, or the ratio is there. Okay, so ratio should be in the several times the rated, so should having the ratio should be in the above rate ratio. Okay, so this is about the requirements of the should. That is one thing is that it should have to withstand the above rated current and should have the ratios with the above rated primary current. Okay, so this is about the current transformer. In the next sessions, we'll talk about what mean by current transformer. Okay, so detail of the current transformer.